In the first section, we were looking at single events, the probability of a single event happening, which was pretty easy. It's the number of times that event could happen divided by the total possible outcomes. Well, what if we have two events happening? Okay, so what if we want to know what's the probability of event A happening or B happening? So that's really A occurring or B occurring or both. So let's think about the situation. If you roll a die, find the probability of rolling a number less than 3 or rolling an odd number. So first, sometimes it's helpful to use a Venn diagram. So we have two situations here. We have numbers that are less than 3, and we have numbers that are odd. Now, there is an overlap there. There is a number that is less than 3 that is also odd. So when we think about Venn diagrams, remember they can have an overlap. So you could have, let's see, this would be the world of, let's call this the less than 3. Less than 3. And let's make this the world of odd numbers. Odd. So there's an overlap of the numbers that are less than 3 that are also odd. That would be the number 1. Now what is less than 3 but is not odd would be 2. What are the other odd numbers that could be rolled? Now would that be 3 and 5? What are the other numbers possible that don't fit into either one of those realms? Well, that would be 4 and 6. So our total number possible is 6. So that's a good thing to know. So find the probability of rolling a number less than 3. So the probability of, I'm just going to say that x is less than 3. Well, that would be 1 or 2. So that would be 2 out of 6, or 1/3. What's the probability of rolling an odd? So the probability of odd, 1, 2, 3. There were 3 out of the 6, or 1/2. But the probability of x being less than 3 or odd, there's a difference there, because when I count those up, less than 3 or odd, if I just counted 2 plus 3, I would have a 5. But it's not 5, because I would have been counting 1 twice. So we have to kind of be careful when it's an or, because there's that possibility of the both, that overlap. So we can't just say, well, less than 3 were 2 and odd were 3, so this has to be 5. It isn't. It's going to be 4 numbers meet that criteria. So this is 4 out of 6. So the technical way that this would be found, I would take the probability of x being less than 3 plus the probability of the being odd, and then subtracting the probability of it matching both. Now, wouldn't that work? We'd have 2 out of 6 plus 3 out of 6, and the both was 1 out of 6. So that is the technical way that we could find this occurrence of or. Let's look at another example of it. The following table presents the results of a survey in which 1,000 adults were asked whether they favored a law that would provide more government support for higher education. In addition, each person was asked whether he or she voted in the last election. So these were the people in favor of the law, opposed, or undecided. and the people likely to vote in the last election and not likely to vote. Okay, so if they voted in the last election, they considered them likely to vote. If they didn't vote in the last election, they were not likely to vote. So what's the probability that a randomly selected adult is likely to vote and favors the law? So probability that they're going to vote and favor the law. Well, that would be vote and favor. That's 372 out of 1,000 total adults. And we could simplify that if we wanted to. I'm not going to for these purposes. What about the probability that a randomly selected adult is just likely to vote? Well, that would be all of these. So I'd have to add 372 plus 262 plus 87. That would be that whole row right there. So I'm going to grab my calculator real quick. That would be 372 plus 262 plus 87. That's a total of 721 people. What's the probability that a randomly selected adult favors the law? So that would be this list. So that would be 372 plus 151. That's 523 people. What is the probability that a randomly selected adult is likely to vote or favors the law? Well, if I'm using this table, vote or favor, that would mean I need to add up the people who vote plus the people that favor, but I already counted that one, so I just need to add the 151 from there. So that would mean I would be taking the 372 plus 262 plus 87 plus 151 and get 872 out of 1,000. Now, what if we did that using that rule that I just mentioned? The probability of A happening plus the probability of B happening minus the probability of both. So the probability of voting plus the probability that they favor, minus the probability that it's both, vote and favor. That overlap. So the probability that they vote was 721 plus the favor was 523 minus the overlap, 372. See if we get the same answer. 721 plus 523 minus 372 gives me 872. Now, sometimes the two events are what we call mutually exclusive. What that means is the two events could never occur at the same time. So let's think about this. If we're rolling a die, could we get an odd number or an even number? Could those happen at the same time? Could we have an overlap? No. These are mutually exclusive, so we wouldn't have to worry about the overlap. What about getting a 5 or getting an odd? That would be not mutually exclusive. getting an odd number or getting a number less than 4? Not mutually exclusive. Getting a number greater than 3 or getting a number less than 3. Could those happen at the same time? No. So those are mutually exclusive. A bag containing 5 green jelly beans, 4 red jelly beans, and 3 yellow jelly beans. If a person selects a jelly bean at random, find the probability that it is either yellow or green. Can those happen at the same time? No. Those are mutually exclusive. So if I'm thinking about the probability of yellow or green, if I think about what the rule actually says, it says we take the probability of yellow plus the probability of green, but I would subtract the probability of it being both. But can it ever be both? No, because it's mutually exclusive. So what's the probability of getting a yellow jelly bean? Well, that would be 3 out of, how many jelly beans are there? There's 12 of them. Plus green, that's 5 out of 12. That gives me 8 out of 12 jelly beans. That's 2 out of 3. Now the last notation I want to talk about is complements. And the notation we use a lot of times is this, I don't know if you can see it very well, A with a little C, or sometimes you might see A with a little dash. And what that means is it's the probability that it doesn't happen. So according to the Wall Street Journal, 40% of cars sold in recent years were small cars. What is the probability that a randomly chosen car in that year is not small? So the probability of being small was 40%. And by the way, probabilities can be fractions, but they can also be percents or decimals. So 40% is fine, because that really means it's 40 out of 100, or 0.40. Still, it's a number between 0 and 1, which is fine. Not small would be small with a little C or a dash. That's not small. Well, that would be 60%. It's the opposite. And that's what a complement is.